Now that we understand what work is, we can talk about potential energy U, which is the capability of a force of doing a work which depends on position or configuration. This is really the key. I have a little example here to understand it better. Let's say you have a ball of a mass m, it could be really any object with a mass, that at a certain time 0, it is at a certain height h. Now we know that every object with a mass is subject to the force of gravity, a force that will take the object, push it down, and bring it to the ground. So after some time, at a time t, the object would have gone from the height h to the ground, so height equal to 0, for example. According to the definition of potential energy, at the time 0, the object has a potential energy equal to F multiplied by h, because in that moment, just because of the position of the object, so here how we connect to the definition, just because of the fact that the object is elevated from the ground, the force of gravity F can act on it and do a certain work. Remember that you have work when the object moves in a certain direction and there is a force applied to it in the same direction, which is the case in this example. At time t, the object is on the floor, there is no net force applied to the object anymore, and the object and also the height is 0 now, so the potential energy is 0 in that case. Work and energy, as you can see, are interchangeable in a way, so they're both measured in joule. One thing that is really important to highlight for potential energy is that the potential energy of an object is not an absolute value. So for example, in this case, we say that when the object is, the ball is at a certain height h, the potential energy is exactly F multiplied by h. In reality, it is possible to demonstrate that every potential energy is defined plus minus a certain arbitrary constant. As long as we apply the same constant to all the other potential energy in the system, everything works. But what does it mean? This sounds a little strange. Now, the energy could be any value. What I'm trying to say is simply that the only things that really matters, the only thing that really has a significance is the difference of energy. For example, between time 0 and time t, the difference of potential energy between the ball is always going to be equal to F multiplied by h. Doesn't matter what is the constant that we add, because when you do the difference, the constant will be simplified. So saying that the ball has energy equal to 0 on the ground, it's perfectly fine, but it's just an arbitrary convention. This is something really important to understand, because potential energy is intimately related to voltage, and the same concept, exactly the same concept, also applies to the voltage. When you say that in a certain point there are 3 volts, in reality, all you're saying is that in that point there are 3 volts more than some other point. It doesn't really mean that that point is exactly absolutely 3 volts. It's simply the difference relative to another point of the circuit.